Okay, we actually did number 5, but I'm going to show you an alternate way to do number 5. So, because remember that when you have, this would be kind of like x squared times e to the x, and because of that x squared, you're going to have to run integration by parts 2 times. And if it had been x cubed times something, we would have had to have done it 3 times. So if you look at what we did, we had to do integration by parts twice. Okay, there's this little shortcut that's called the tabular method or a table method. And what we're going to do is we're going to make a table out of this. We still have to identify our u and our dv. And we still want to try and let u be the polynomial, the x squared. Okay, so that's what we're going to do. So if u is x squared, then dv is going to have to be the sine x. Now, what we're going to do is we're going to take the derivatives of u until I get down to 0. So the derivative of x squared is 2x, and the derivative of that is 2, and the derivative of that is 0. All right, now, however many times I had to take the derivative to get down to 0, I'm going to integrate the other side that many times. All right, so it's the integral of sine. Negative cosine, very good. And then negative sine, and then cosine. Okay, I'm going to check this. The derivative of cosine is negative sine. Derivative of negative sine is negative cosine. The derivative of negative cosine is sine. Okay, that works. All right, now I'm going to start with my first u, and I'm going to start with a plus, and then I'm going to go down and go plus, minus, plus, minus. And, you know, this is just kind of a shortcut, so there's not, I mean, you're just going to have to go with me, and this is the way you do it. So you do your u's, take the derivatives to 0, integrate, and then make a column of plus, minus in front of your u's. Now, I'm going to multiply diagonally, kind of. So I'm going to go like this. And then I'm going to go like this. And then I'm going to go like this. And then 0 times anything would just be 0. So what I'm going to do is I'm going to multiply the diagonals and then add all of those together. So I have positive x squared times negative cosine x. So that's negative x squared cosine x. Plus the product of the next two. Negative 2x times negative sine x is 2x sine x. 2x sine x. And then I'm going to add the product of the next two, which is 2 cosine x. Plus c, and I'm done. Okay, so you're complaining about that at first, but it's a nice little shortcut. Okay, now, the first question I'm sure you're going to say is, why didn't you show us this from the very beginning? And that is because you can't always use this. You can only use this when what you're letting u be goes all the way to 0. Okay, so like if we were integrating x ln x, if we were integrating x ln x, my first instinct is to let the x be u, but then dv would be ln x, and I can't integrate ln x. So I would have to let u be my ln x and dv equal the x, and my u does not go to 0, so I cannot use that method. So you have to know how to do integration by parts, but this is just a shortcut for basically any time you might have to use integration by parts more than once. All right, so that's a little shortcut. And then we're going to use that again on number 7, but unfortunately we can't use it on number 6 because my two functions are e to the x and cosine 2x. Do either of those derivatives end up going to 0? No. In this case, it really doesn't matter which one you let u be and which one you let dv be. I would just pick dv of the one you would rather integrate. Would you rather integrate e to the x, or would you rather integrate cosine 2x? Okay. And you know what, guys? I'm going to make this a little bit simpler. We're just going to make this cosine x. All right, so we've got u and we've got dv. So even though I'll just have cosine x as opposed to cosine 2x, I think I would rather integrate e to the x than integrate the trig function? Are y'all kind of on the same page? All right. Well, it's not hard, but I think better in terms of the derivatives of the trig functions as opposed to the integrals. Literally, it does not matter. All right, so what's du going to be? Negative sine x. What's v going to be? E to the x. No dx. Okay, uv is e to the x, that's not a negative, cosine x, minus super voodoo. V du. I'm going to pull the negative out and make it plus the integral of e to the x sine x. Okay, Harry, why'd you say oh no? Okay, we're going to have to do it again. Okay, well, the formula is minus super voodoo, but instead of doing minus the integral of negative e to the x sine x, I pulled the negative out and made that plus. Okay, so now you got to stay in the same family. So if u is the trig function to begin with, it needs to stay the trig function. So u is sine x, and dv is e to the x. So du is cosine x, and v is e to the x. It's not endless, I promise. Okay, so we have e to the x cosine x plus my new ultraviolet minus super voodoo, which is e to the x sine x minus the integral of e to the x cosine x. It is. It looks endless because that's kind of what we started with, right? All right. But doesn't this whole thing that I have written right here on this last line, doesn't this whole thing equal my original problem? Okay, so this whole thing equals the integral of e to the x. Okay, hold on. We'll get there. This whole thing that I did, I'm not cheating. This whole thing that I've been working on equals this original integral, e to the x cosine x. Well, I've got some like terms here. I have the integral of e to the x cosine dx on the left, and I have a negative integral of e to the x cosine dx on the right. So I'm going to add an integral of e to the x cosine x dx to both sides. Okay, if I had just say j equals e to the x cosine x plus e to the x sine x minus j, then I could add j to both sides. I'm just combining my like terms. All right, so on the left side, I have two integrals of e to the x cosine x dx. And on the right side, I just have the e to the x cosine x plus e to the x sine x. And just divide by 2, and I'm done. Yes, and then I have to do a plus c. The way that you recognize these problems is that it's pretty much always going to be an e to the x times a trig function, either sine or cosine, because I'll be nice to you. None of the derivatives will go to 0. It doesn't matter which one you pick for u and which one you pick for dv.
Now on number 7, we can use the chart method. So, and the book calls this the tabular method. So if you see that in the book, it's the same thing. All right, so we always want to let u be the part whose derivative will go to 0. So that has to be x squared. And we take its derivative all the way to 0. So 2x, 2, and 0. And then dv, by default, will have to be the sine 2x. All right, now when we integrate sine 2x, remember that when you integrate sine, you get negative cosine 2x, but we also need to put a 1/2 out in front to compensate for that 2. So it's negative 1/2 cosine 2x. And you could always have let u be 2x and done a u substitution here. But another way to think about it is the derivative of cosine 2x is negative sine 2x times the 2 because of the derivative of 2x. So we need that 1/2 to compensate for that. So now when we integrate negative 1/2 cosine 2x, I'm going to get negative sine, but I need to multiply by 1/2 again, so I have negative 1/4 sine 2x. And then integrating one more time gives me 1/8 cosine 2x. All right, so then I have to remember to do my plus minus in my u column. Okay, so when we multiply by the diagonals through here, like that, then our answer will be x squared times negative 1/2 cosine 2x. I'm going to write that as negative 1/2 x squared cosine 2x. And then I'm going to multiply negative 2x times negative 1/4 sine 2x. And I'm going to write that as positive 1/2 x sine 2x. And then 2 times 1/8 cosine 2x is 1/4 cosine 2x. And we are integrating here, so don't forget your plus c. And that's your final answer. And you could have gotten that exact same answer doing the ultraviolet minus super voodoo. You just would have had to have done 2 rounds of it. So in this case, the little chart method is much easier. All right, try number 8 on your own. Pause the video and work number 8 using the chart method. And when you're finished, then restart the video and check your answer. Okay, so your u needs to be x cubed and the dv e to the x. If you take the derivatives all the way down to 0, then when you multiply, you are going to get e to the x, x cubed, minus 3x squared e to the x, plus 6x e to the x, minus 6 e to the x, plus c. And you're finished. And I'm not sure why I put the x cubed second on that first term. It doesn't really matter. All right, that's it.